Good day, everyone. I am Engine Cadet Magali Jabertsi, and our topic is all about ship power supply and emergency power supply. And this topic will be discussed by my teammates, Engine Cadet Ipili Mark Jade, Engine Cadet Gadian Jan Aiken, Engine Cadet Isolana Benji, and Engine Cadet Omayan Albert. The learning outcome of this video presentation is that the cadets must be able to describe the power supply system on board ships and its backup procedures and system during blackout emergency. As an aspiring marine engineering someday, we come to ask a question: if how is power generated and supplied on a ship? This is actually a very interesting topic since we talk about if how power is being generated and how is it being supplied and how is it being preserved in a ship. So if here in land we have Sibeco, we have Meralco, wherein it provides us electricity every day. So how about in ships? A ship is like a floating city with all the privileges enjoyed by any normal land city. Just like a conventional city, the ship also requires all the basic amenities to sustain life on board. The chief among them is power or electricity. In this article, we will learn as to how power is generated and supplied on board a ship. And furthermore information about this will be discussed by my teammate.
A pleasant day, sir, and to all the cadets. This is Engine Cadet Linja Isolana, and I'm gonna tackle about the power generation on board. Shipboard power is generated using a prime mover and an alternator working together. For these, an alternating current generator is used on board. The generator works on the principle that when the magnetic field around a conductor varies, a current is induced in the conductor. The generator consists of a stationary set of conductors wound in coils on an iron core. This is known as a stator. A rotating magnetic core, the rotor, turns inside the stator, producing magnetic field. This field cuts across the conductor, generating an induced EMF or electromagnetic force as the mechanical input, causes the motor to turn. The magnetic field is generated by induction in a brushless alternator and by a rotor winding energized by DC current through slip rings and brushes. By the way, the slip rings are electrical connections that are used to transfer power to and from the rotor of an AC generator. It consists of circular conducting material that is connected to the rotor windings and insulated from the shaft. So this is the few points to be noted about power on board. First is the AC or the alternating current. Three-phase power is preferred over direct current as it gives more power for the same size. Second is three-phase is preferred over single phase as it draws more power, and in the event of failure of one phase, other two can still work. And that's all. Then for the next, it will be continued to the next reporter.
Good day, everyone. This is Engine Cadet Ipili, and I'm going to discuss about the power distribution on board a ship. So the power distribution on board a ship needs to be supplied efficiently throughout the ship. For this is the power distribution system of the ship is used. A shipboard distribution system is composed of different components for distribution and safe operation of the system. And they are as follows. First, the ship generator consisting of prime mover and alternator. So when we say a prime mover, it is a machine or it is a diesel power or something like a machine that's creating a mechanical force, and then an alternator, which is the one that's creating a power or the voltage that will supply to our ships, and that is called the generator. The second is the main switchboard, which is a metal enclosure taking power from the diesel generator and supplying it to different machinery. Now when we say main switchboard. So it is a metal enclosure taking power from the diesel generator. So all the power from the diesel generator that the diesel generator is creating is supplied to different machineries, but it is being controlled in the main switchboard. Okay. The third is the bus bars, which act as a carrier and allows to transfer of load from one point to another. Circuit breakers, which act as a switch and in unsafe condition can be tripped to avoid breakdown and accident. Fuses are a safety device for machineries. Okay, so bus bars. Bus bars is very important. Okay, so when we have on board the ship, if we have 4 generators, we have the diesel generator number 1, we have the diesel generator number 2, we have the shaft generator, we have the turbo generator, and we also have emergency generators. In order for us to make to use that kind of generator, we need to synchronize that one, and we need to connect it to the bus bar before it will be synchronized. Okay, so the bus bar is very important. Now, when we talk about circuit breakers, a circuit breakers is a device that acts as a switch in an unsafe condition. Say, for example, if there are shortage current, right? So the circuit breakers will automatically trip to avoid accident or breakdown. And then fuses, also a safety device in machineries. Now, the fourth is the transformer. A transformer is to step up or to step down the voltage. When supply is to be given to the lighting system, a step-down transformer is used in the distribution system. Now, why is it? Now, we already know that we have a 440 volts on board the ship. Now, why we use a step-down transformer? It is because the lighting systems is an essential to our ships, because lighting system is very important for us to communicate to other ships. Okay, so now the lighting is using only a 24 volts. Okay, so we need to use a step-down transformer in order to consume that voltage. Okay, so the fifth is in a power distribution system. The voltage at which the system works is usually 440. Now, this is it. So, what the diesel generator number 1, 2, they all create a 440 voltage. Okay, so the sixth is there are some large installation where the voltage is as high as 6,600 volts. Now, when we talk about that, so say like for example you're using a 440 volts, okay, of the moment that the ship is in anchorage. Okay, now when we are going to maneuver the ship, so we need to make sure that the ship is equipped with a high voltage, so that if the first generator will trip, so there will be another generator that will take over to get all the load. So that's because of there are some installation where the voltage is high as 6,000 volt. Now, the seventh is the power is supplied through circuit breakers to large auxiliary machinery at high voltage. So there are circuit breakers that are actually high voltage circuit breakers. So and we know about that one. Now for the eighth, for smaller supply fuse and miniature circuit breakers are used. Okay, so if we have smaller supply fuse, so we don't need to use a large circuit breaker. So we need just to use the MCB or the miniature circuit breakers. Okay, so the ninth is the distribution system is 3-wire and can be neutrally insulated or earthed. Okay, so and the 10th is insulated system is more preferred as compared to earthed system, because during an earth fault, essential machinery such as steering gear may lost. Okay, so since our steering gear is very important on board a ship, because it is the one that makes our ship to go on the starboard, to go on the port side, it may made the rudder to to move. So it is very important that it will not be folding. Okay, so there is it's just a one-time accident if we lost, especially if we are maneuvering. Okay, so that's all for this time, and I'll pass to you to the another report. Thank you so much and have a good day.
Hello everyone, I am Engine Cadet Gadjan, Jan Aiken, and I am here to tackle about the understanding the blackout condition. So, blackout condition is a scenario on a ship wherein the main propulsion plant and associated auxiliaries stop operating due to failure of power generation system of the ship, which is the generator and alternator. So, with this kind of situation, those essential machineries fail to have power because the generation or the generator and the alternator gives less power or no power at all. That's why it causes blackout, total blackout to the ship. But with technologies and automation, measures are provided to avoid such blackout situation by means of auto loading sharing system and auto standby system, in which the generator set that is running in parallel or standby comes on load automatically if the running diesel's generator fails.
What to do in case of a blackout? In case of blackout, following precautions and actions should be taken. Before starting the generator set, start the pre-lubrication priming pump if the supply for the same is given from the emergency generator. If not, then use a manual priming handle provided in some generators. Start the generator and take it on load. Then immediately start the main engine lobe oil pump and the main engine jacket water pump. Reset breakers and start all the other required machinery and system. Reset breakers that are included in preferential tripping sequence. It requires both skill and patience to tackle a situation like blackouts, especially when the vessel is sailing or maneuvering. However, the best way to tackle such situation is to be calm and composed, and to know your engine room and machinery very well in advance. Next is what to do in case of blackout. In case of blackout, following precautions and actions should be taken. Never panic in such a situation. Be calm and composed. An emergency generator will restore and power in no time. Inform officer in bridge briefly about condition. Call for manpower and inform the chief engineer. If the main propulsion plant is running, bring the fuel lever to zero position. Close the feed of the running purifier to avoid overflow and wastage of fuel. If the auxiliary boiler was running, shut the main steam valve to maintain the steam pressure. Find out the problem and the reason of blackout and rectify the same. That's all. Thank you.